When Filipino engineers presented their bamboo construction plans at an international conference in Singapore, the room fell silent. Then came the laughter. European structural engineers exchanged knowing glances, their expressions saying everything their words didn't need to. Bamboo for modern buildings? In the 21st century? The idea seemed absurd to those accustomed to steel beams and reinforced concrete. But what these skeptics didn't know was that they were about to witness one of the most remarkable material revolutions in construction history. The Philippines has been quietly engineering the future while the rest of the world clung to carbon-intensive materials that are destroying our planet. For decades, bamboo was dismissed as poor man's timber, a material suitable only for temporary structures in rural villages. The stereotype was so deeply ingrained that even architects in bamboo-rich countries preferred imported steel and concrete, believing these materials projected wealth and progress. But Filipino innovators saw something different. They saw a material that grows 10 times faster than trees, absorbs more carbon dioxide than most plants, and possesses a tensile strength that rivals steel. Dr. Mundo pioneered this thinking back in 1941 when she created the bamboo incubator. While working as a pediatrician, she noticed that premature infants in rural areas had no access to the expensive electric incubators used in hospitals. Rather than accept this reality, she designed a solution using 2 bamboo laundry baskets of different sizes, placed one inside the other. Hot water bottles regulated the temperature between the baskets, and she added a small hood with oxygen supply. This simple yet brilliant design saved thousands of newborn lives across the Philippines. Dr. Del Mundo became the first female national scientist of the Philippines and received the Ramon Magsaysay Award. Her bamboo incubator proved that Filipino ingenuity could solve complex problems with local resources. Fast forward to recent years, and the Philippines has taken bamboo innovation to unprecedented heights. Companies like Rizome Philippines established a manufacturing center in Cagayan de Oro City where they transform bamboo into engineered building materials with the performance characteristics of steel and concrete. The process involves treating bamboo to make it durable and resistant to insects, then laminating the fibers into structural components. These aren't flimsy materials for garden furniture. We're talking about load-bearing beams, architectural panels, flooring systems, and structural frameworks that can support multi-story buildings. The numbers tell an incredible story. Bamboo grows to maturity in just 3 to 5 years, compared to decades for hardwood trees. During its growth cycle, bamboo removes carbon from the atmosphere at rates that make it one of the fastest natural carbon removal systems on Earth. When harvested, the plant doesn't die, but regenerates from its root system, continuing to sequester carbon for up to 100 years. Every cubic meter of bamboo building material removes approximately 250 kilograms of carbon dioxide from the atmosphere. Compare that to steel production, which requires 50 times more energy than bamboo processing. But here's where the story gets really interesting. When Filipino engineers presented Project Beam in early 2026, they unveiled the Philippines' first commercial-scale bamboo structure. This wasn't a demonstration project or an art installation. This was a real building, designed to meet all the rigorous requirements of modern construction codes. The project brought together developers, designers, engineers, contractors, manufacturers, and policymakers to prove that engineered bamboo could be implemented with the discipline required for commercial applications. The international construction community had to confront an uncomfortable truth. The countries with expertise in developing construction codes and building regulations were not the countries interested in bamboo. Western engineers had spent decades perfecting standards for steel and concrete while ignoring sustainable alternatives. Meanwhile, Filipino engineers were solving real problems. They were creating affordable housing, reducing carbon emissions, and building supply chains that empowered rural communities. Indigenous groups in Mindanao now have long-term agreements with bamboo companies, turning agroforestry into a reliable source of income. Research institutions worldwide are now scrambling to catch up.